Hello everyone. Welcome to DCC NIT-A YouTube channel. Today we will be solving problem C, which is search in parallel from Codeforces round, educational Codeforces round 146. So I hope you have already read the problem. Problem statement is quite long. So I will encourage you to read it yourself first and try to understand what the problem says. I will just walk you through the problem quickly. Suppose we have n boxes and ith box contains infinitely many balls of color I. Sometimes you need to get a ball with some specific color, but you are too lazy to do it yourself. So what the problem says, we have given n box. So suppose this is box 1, box 2, box 3, box 4, box 5, and uh, and uh, and box one have balls of color one, infinite balls. Box two have balls of color two, infinite number of balls. Box three have balls of color three, infinite numbers. So this will have as many balls we can pick. So will have as many ball you can say. And similarly in box 4 and box 5. And here we are not representing color as blue, red, green. Here we are representing color as numbers. So color 1, color 2, color 3, color 4, color 5. So in the box 5, color ball of color 5 will be infinite number of. So in the box 4 there will be infinite number of balls of color 4. So I hope this statement is clear. So now let's go into the problem. So you have bought two robots to retrieve the ball for you. Now you have to program them. Okay, in order to program the robots you have to construct two lists, a1 a2 to ak and b1 b2 to bn minus k, where list a represents the box assigned to first robot and list b represents the box assigned to second robot. Okay, and every integer from 1 to n must be present in exactly one of these lists. Okay, so it is saying, so we have two robots, robot 1 and robot 2, and it is saying suppose n equals to 10. So we have 10 boxes. So you will have two lists. Suppose if first list have three numbers, then second list have n minus 3, that is 7. If first list have four numbers, then second list will have n minus 4, which is 6. So this will have, suppose this have three numbers and this have seven numbers. So this will have suppose 7 and 5 and 2. So then this box will have 1, 3, 6, 4, 4, and so this 4, 9, 8, 10, 2, 3, 4, 5, 6. So if you look at all these numbers and if you look at all these numbers, so these two contains all the number from 1 to 10. And suppose this list is assigned to robot 1 and this list is assigned to robot 2. So this is the problem till now. Now let's go further in the problem. So when you request a ball with color X, the robot works as follows. Each robot looks through the boxes that were assigned to that robot in the order they appear in the list. The first robot spends S1 second analyzing the content of a box. The second robot spends S2. As soon as one of the robot finds the box with ball of color X, the search ends. The search time is the number of seconds from beginning of the search until one of the robot finishes analyzing the content of X box. If a robot analyzes the content of all boxes assigned to it, it stops. So here is an example. So you can look at this example yourself. So I will just try to copy it and explain it to you. So, so So S1 equals to 2 and S2 equals to 3. That means robot 1 and robot 2. So robot 1 takes 2 seconds to analyze a box. Robot 2 takes 3 seconds to analyze a box. So for robot 1, the list is 4, 1, 5, 3 and 7. For robot 2, the list is 2, 6. Okay. Now, Now suppose we start from second 0. Now we go to the second 1. So at 1 second, neither robot 1 can analyze a box, neither robot 2 can analyze a box because it needs 2 seconds and it needs 3 seconds. Now we are at 2 second 2. So at 2 second, in 2 second, robot 1 can analyze one box. So suppose it analyzes this box. Okay. And here we have to find box number 3. Okay. And this is not box number 3, so it goes to the next box. Now we are at third second. So in the 3 seconds, robot 2 can analyze a box. So this analyzes this box and this has ball of color 2. So it is not the ball of color 3, so it goes to the next box. Okay. Now we are at fourth second. So at the fourth second, robot 1 can analyze the second box because it analyzes each box in 2 seconds. So at the fourth second, it can analyze the second box. Okay. So it looks at this box and this box is of color 1. So it goes to the next box. Okay. Now we are at suppose at second fifth. So at fifth second, the neither robot 1 can analyze any box and neither robot 2 can analyze any box because to analyze the second box, uh, robot 2 will analyze second box at 6th second, then third box at 9th second. Similarly, robot 1 will analyze first box at second, second box at fourth second, third box at sixth second. So I hope you get it. So at fifth second, none of the robot can analyze any box. So now we are at sixth second. At sixth second, it robot first will analyze the third box. Robot one will analyze the third box. So this is fifth box of color 5 and not of 3. So we will go to the next box. And similarly at sixth second, robot 2 will analyze this box and this is of color 6, not of 3. So it will go further. And here this list ends. So search for robot 2 ends. Now we are at 7th second. At 7th second, search for robot 2 has already ended, and at 7th second, robot 1 can't analyze any box because robot 1 will analyze next box at 8th second. Now we are at 8th second. So at 8th second, robot 1 analyzes the this box and this is of color 3. So here search ended. We have found the box with color 3. Okay. I hope the problem is clear till now. So what the problem says next? So problem says you know that you are going to request a ball of color 1 R1 times, ball of color 2 R2 times, and so on. You want to construct the list A and B for the robots in such a way that the total search time over all requests is minimum. So what does this mean? Let me copy this test case so that you can understand better. Okay. Okay. So the first test case is 7, 3, 1 and 8, 6, 4, 4, 4. Wait a minute. 4, 1, 7. So what does this mean is this is n number of box. This is S1 time taken by robot 1 to check each box, and this is S2 time taken by robot 2 to check each box. And this is first box, second box, third box, fourth box, fifth box, sixth box, seventh box. Now what is this 864? This 8 is you are going to check the first ball number 1 8 times. So let's go back. So here we had query to search for the box with ball with color 3. So we found box with color 3 here. Here we found. Okay. So suppose we had to do this 2 times. We already know that we have to search for box with color 3 2 times. Okay. So we will try to keep this 3 in front because we are always searching for boxes in sequential manner. That means we are going from starting till the end. So we will try to keep this box at front so that we find this box as soon as possible. Okay. So that's what it is saying. It is saying you already know that you are going to look for box with color 1 8 times, box with color 2 6 times, box with color 3 4 times, box with color 4 4 times, box with color 5 4 times, box with color 6 1 times, and box with color 7 7 times. So since we already know that we are going to look for box with color 1 8 times, we will try to arrange both the list in such a way that we find the first we find the first box as soon as possible. And since we know that we are going to look for the box with color 6 only one times, so we will try to keep it in the last, so that because we don't want to go till the end every time, so we keep that box in last, which we need to visit lesser number of times, and we want to keep that box in front, which we need to visit frequently. Okay, so how are we going to implement this? How are we going to implement this? So first, what will we do? We will we will arrange it in descending order based on the number of times we are going to visit it. So how are we going to arrange it? We will arrange it as 8 7 6 4 4 4 1, and this was box 1, this was box 7, this was box 2, this was box 3, this was box 4, this was box 5, and this was box 6. Okay, now now we have now we have s1 equals to 3 and s2 equals to 1. So we have s1 equals to 3 and s2 equals to 1. Okay. So suppose this is, so what will we do? We will go here. So how will we keep track of which box, which ball we have to keep in which which array list, and which ball we have to keep in which array list? Because we will have two array lists, one array list for robot 1 and one array list for robot 2. So we will simply keep a array B of size n, and suppose this was the ball number. Suppose ball number 3, we know that we have to keep in the array list of robot 2. So here we will simply put 2. Suppose this was box number 9, and we found that we need to keep ball number 9 in the array list of robot 1. So we will put 1, and by this array we will find it later that which ball to keep in the array list of which robot and not. Okay, so now let's understand the process first. So so this is the this is this is in descending order, and this is the ball number 1 ball number. I am saying ball number because it is quite confusing to say ball number with color 1 color 7, because basically it will do the same thing if we call it ball number or color number, your preference. I will just call it ball number. So ball number 1, ball number 7, ball number 2, ball number 3. So question boils down to we need to visit ball number 1 8 times, ball number 7 7 times, ball number 2 6 times, ball number 3 4 times, ball number 4 4 times, ball number 5 4 times, and ball number 6 1 time. So now we want to adjust these balls in array list, this and this, in such a way that we need minimum time to visit all the balls. Okay, so we will be visiting ball 1 8 times, ball 7 7 times. So we will want to keep these balls in front of any of the array so that we visit it as soon as possible. So now let's go through the time. So at t equals to 0, we can't visit any box. Okay, so at t equals to 1, so at t equals to 1, robot 2 will be, so robot 2 need 1 second to visit per ball, and robot 1 need 3 second. So at 1 second, robot 2 will be able to visit one box. So we will want to keep this keep this ball in here. So here we will put 1. Okay, here we will put 1, and this is for robot 1 and this is for robot 2. Now we go to the time 2. Now at time 2 second, robot 2 will be able to visit the second box, because robot 2 will be able to visit the second box. So this is the second box we will put here, because we will be visiting balls in this direction. So we want to put all those balls in front, which we need to visit maximum number of times. Okay, it's quite obvious. Now we are at say third second. So at third second, robot 2 will be able to visit the third ball. So third ball is this. This is in descending order. Third ball means third ball with maximum frequency. So here we will put 2. And at the third second, robot 1 will also be able to visit one ball. So robot 1 will visit, suppose, this ball. So robot 1 will visit third ball. Okay. Now, at fourth second, robot 2 will be able to visit the next ball with maximum frequency, which is fourth ball. So here we put 4. Now at fifth second, robot 2 will be able to hit the next ball with maximum frequency. So this is the next ball with maximum frequency. So here we put fifth ball. And at sixth second, robot 1 will be able to hit the next ball, and robot 2 will also be able to hit the next ball. So we can put this sixth at here or here. It doesn't matter actually. We can put here or here. Similarly, when we were at third second, both robot 1 and robot 2 were able to visit one box. So so visit one. So at third second, both the robot were able to visit one box, and we had more than two boxes left. So we put a box here, third box, and we put a box here, that is fourth box. But now we will have only one box left, which is sixth box. I mean sixth ball. You get it, okay? Sixth ball. So we put sixth ball here or here. It doesn't matter. Suppose I put here, then it will also give correct answer. If you put here, it will also give correct answer. Now let's walk through the code. So the code is quite simple. So we take the input here. S1 is the time for robot 1 and S2 is the time for robot 2. We make a vector of pair, and this is x is frequency and I is the ball number. Okay, so initially we are taking ball number as 0 0 1 2 3 till 0 1 2 3 till n minus 1, and when we will be printing we will just add 1 to all these balls, so that answer is 1 indexed, because we have to print answer from 1 to n. Ball are numbered from 1 to n. Initially we are taking according to index, so it is 0 to n minus 1. When we are printing it, we are just adding 1 to the index. Okay, you get it. So then we are sorting the vector. As I said, we will sort the vector in the descending order according to the frequency. So 8764441. So we sort the vector in the descending order, and since first value of the pair is the frequency, so it will sort according to the frequency. Now we take T1 as minimum of S1, S2, and T2 as minimum of S1, S2, maximum of S1, S2. So what it means is, just to simplify things, suppose S1 was 3 and S2 was 1. So we are just making T1 equals to 1 and T2 equals to 3, just to simplify things for ourselves. Okay, and this array of B of n is what array? So I told you we will just make a array so that we can put in the array list last. So array B will be like this. Suppose we have four elements. So 0 1 2 3. So at third index, when we are traveling through this, and suppose when we were at tooth second. So when we are at, suppose, fourth second, so we know at fourth second we can visit this box, and which robot will be able to visit this box? Only second robot will be able to visit this box. So at, suppose this was 5, so this is 4. So at fourth index we will just put 2, so that we will know that second robot, we have to put this ball in the array list of second robot. Okay, this is the work of that array B. Now we take a index start equals to 0. So start equals to 0 index simply means we are starting from here, and we are going until the array is covered or fully covered or not. So when the array is fully covered, we just break, we check it everywhere. So if whenever start goes beyond n, we just break it. Now you can just look at the code and you will understand. So R1 is the time starting from 0. So time starts from 0, and whenever it reaches time t1, we just we just we just know that we can visit this ball, and if robot 1 is able to visit this ball, we put we robot 1 is able to visit this ball. So what will we are doing, we are suppose this was the index 2, and we know that robot 1 is able to visit this ball. So at index 2 we just put 1, so that later we will know that ball number 1 has to be in the array list of robot 1. Okay, so this is the code, and finally we just make two arrays. We just make two vectors, v1 and v2, and in the vector v1 we put all those balls which are to be visited by robot 1, I mean array list of robot 1, and vector v2 is just the array list of robot 2, and we just print it. So if you have any doubt, still any doubt, I will highly encourage you to try it yourself. If you still have any doubt, just leave a comment, and I will try to help you as much as I can. Thank you for watching.